Okay, thank you very much for coming to my session. So first, please remember this microcontroller board. So later I explain this one microcontroller board. Okay, later. Okay, let's start my session. My topic is about mruby and data flow programming environment. So first of me, I'm Tanaka from Kyushu Institute of Technology, Japan. I'm a faculty member, yes. And I have a lecture about data structure, algorithms, image processing, sensors, and so on. And also I'm researching about embedded system, so small microcontroller operating system, real-time operating system, and so on. And also IoT systems. And recently I researched about wireless communication, low power wireless communication. And also I belong to some association and some activities I am now doing. Ruby Association, thank you very much, Ruby Association, and Ruby Forum in Fukuoka, mruby Forum in Fukuoka, and Ruby Business Council, that is named as well known as RubyKyo, yes. And also mruby and mruby-C committer. So before starting my topic, recent research topic is wireless communication, low power wireless communication. That stands for the LPWA wireless communication I'm now researching. This wireless communication is maybe opposite side of the 5G or 6G or next generation wireless communication. Very opposite side, like 0G, very opposite side. Because the transmitting speed is very low, about 1 kilobit per second, or very low. And, but low power consumption, and also the wide area is covered, about 15, 20 kilometers by one small module. Very good for the IoT devices. This technology applied to the local government wireless communication. Because usually local government is no money, so they want to use such low-cost wireless communication for local government monitoring. This activity is applying for the disaster prevention. In Japan, you know, the many disasters, strong rains, landslide, typhoon, or something, earthquake, or something, many things. Local government want to get a sensor value from local government area, field. But no money. So low-cost wireless communication is applying to this area. This is my work, pilot experiment of this work. So this is a wireless module and battery, solar panel, and so on, and getting a sensor value, usually rain strength, wind meter, temperature, or light sensor or something, getting sensor values and transmit to the local government office, headquarters local government office. Then the local government staff analyze the sensor value and next action they decide. This experimentation is now ongoing in Fukuoka and Fukushima and Miyagi prefecture. Okay, so the topic. The topic is about mruby and data flow programming environment. So this is a programming environment. First, I show you the demonstration. This one is just blinking LED, two LEDs, red and green LEDs are blinking. That's all. That is interesting or not? Maybe not interesting. But I talk about this mechanism of this device and the mechanism of the mruby and the data flow programming. Okay, demo is okay. So that's blinking LED. Then I talk about these topics. First, what is mruby-C? mruby or mruby-C? This is like a Ruby language. Yes. And data flow programming. What is data flow programming? Next topic. And finally, I talk about integrating mrubyc execution environment and data flow programming. Okay, first is mrubyc. So mrubyc is designated for the small devices. Ruby language, as you know, Ruby language is using in web application, web server or some computing server or some places that they have many memories, many processing powers. That is a very rich environment. But my focusing point is that is small devices, IoT devices, that area. That area is usually the memory processing power is processing power is limited. So mruby and mrubyc developer is how to adapt such Ruby language into small devices. Then we implement mruby and mrubyc. So mrubyc is a more smaller Ruby, like a smaller Ruby. Concept of mruby is so reduce the memory consumption, memory footprint in execution time. That is the point. The laptop developing environment is a laptop or a PC. That is a very rich environment. So no need to such restriction, no need to caring about such memories and processing powers. But in execution environment, that is small devices. So we must reduce the memory and reduce the processing power. That is the concept in execution time, only execution time. Okay, and source code is developing in PC. That is okay. Execution time is compiled code. Compiled code is compiled in developing environment PC, and generated bytecode should be transmitted to the microcontroller. Then the microcontroller is executed by this virtual machine, mruby virtual machine. And also mruby has many libraries, mruby gem, like C Ruby gem, very similar. But design is very different. mruby gem. We have many mruby gem libraries. Okay, here is a comparison with Ruby, mrubyc. Here, Ruby is usually requires 1 megabyte or more memories, maybe. And mruby is more smaller, about 128 kilobytes. That you need the kilobyte. And mrubyc is more smaller, 20 kilobyte or around that. Very smaller memory consumption. The targeting device is Ruby is of course the server or PC, laptop, anything. mruby is one board computer, like a Raspberry Pi, one board microcontroller. And mrubyc is targeting mrubyc is one chip microcontroller, one chip. So memory and processing unit and some other IOs are integrated in one circuit. That is a one chip microcontroller, very small microcontroller. So targeting is small devices, low power, low cost. Low power is low cost. And low power is small memory consumption is long time operation. Because you know the CPU and the memory the combination is the base of the processing, computer microcontroller processing. CPU is we can cut the CPU power, the low power consumption or deep sleep mode or something. Then CPU can stop. We can stop the CPU processing. That is a very low power consumption. That is okay. But the problem is memory. Memory is always consume the powers, electricity powers. So memory is SRAM or DRAM. Both memory is they are always consuming powers. So small memory is good for the small devices and small IoT devices. So memory space equals to memory consumption in small microcontroller. Okay. So mruby provides many features, memory management. In this microcontroller, we don't have operating system, so bare metal implementation. So memory management is inside mruby virtual machine. And also power management, of course, power management. Cut the CPU power, resume the CPU power, and so on, controlling. And also the real-time processing, semi-real-time processing. Real-time processing is required. This device is sometimes used for, mruby is sometimes using for the controlling, machinery controlling. In such area, the real-time processing is necessary. So semi-real-time processing is available by mruby virtual machine. So this is R board, mruby ready microcontroller board. This one is also. This one is a very small memory. You see the SRAM is 64 kilobytes, very small. Flash memory is 256 kilobyte, very small. And several IOs here. Okay, this is the mruby execution diagram. So first, we implement Ruby code, so mruby code. mruby and Ruby code is the same. mruby code and compiled into byte code. Byte code is a binary code, compiled byte code. But this byte code is device independent code. So this byte code can transmit to any microcontrollers, any architectures, no problem. And in the small devices, transmitted byte code is executed by a virtual machine. This virtual machine is already deployed as a firmware, like this. So hardware and HAR is hardware abstraction layer is provided from mruby and mruby virtual machine. Virtual machine is processing virtual machine. And byte code. So byte code is executed on mruby and mruby virtual machine. Okay, so what is hardware abstraction layer? So we want to port many devices into many devices. This one is the one example, but another many devices we want to port, deploy to many devices. So we also provide hardware abstraction layer. Some libraries, hardware accessing libraries is prepared, provided. So virtual machine and HAR. So many HAR, several HAR is available. So ESP32 processing hardware abstraction layer libraries, or several libraries mruby is providing. So you can choose which library, which HAR is applied to your virtual machine, then build. Then you can get your own virtual machine for your own devices. They are available on GitHub. Okay, this is the mruby. So conclude about the mruby. mruby is a Ruby language for small devices, small microcontrollers, and compiled on the laptop. And generated byte code should be transmitted to the microcontroller. Then execute. That's all. That is the mruby environment. Okay, next is data flow programming. Data flow. So recently, educational field like junior high school student want to learn about the information subject in the high school, junior high school. At such schools, sometimes visual programming is using. They are popular visual programming environment. The left side is block programming, like a Scratch or Blocky or some visual programming environment is we can use. And right side is data flow programming. This is a node-RED environment, or some environment is available. So they are very useful for the education because they can understand by seeing the blocks, seeing nodes. Then they can understand. They will understand the behavior or logics of the programs. After that, they code into the coding. Okay, so first, block programming. This is named small Ruby. So block programming environment for Ruby language is small Ruby. This is mainly using at the educational environment, schools and so on. So this is a very entry of the procedural programming. Procedural programming is so step by step, line by line. That's the procedural programming is the base of the recent programming language, Ruby, C language, Java, anything. They are procedural programming. So like this one, this figure is showing about the blocks. Left side the blocks. Block is this is a repeating block, and some sentence and delays or something is here, and directly converted into the Ruby language here. Then we write a Ruby code without knowing the Ruby syntax, Ruby grammars, and so on. So block is very easy to understand, easy to implement the some programming, software like this. But I know that some students in junior high school, they first they implement by the block arranging. So long program they want to write, but soon they tired because many blocks should be drag and drop many places, and so ordering, change the ordering or some moving or something very tired. They tired. Then finally they change to the coding, just coding. Copy paste. They easy to understand. But initial entry point is block programming is very good because the logic they understand, the student understand. But that is very tired. Soon they go or enter to the coding style, copy paste like this. So this is a one visual programming environment, block programming environment. This is also popular. And the next one is data flow programming. Change the title. Data flow programming environment. Data flow programming environment is very fit to the IoT programming because the IoT is sensing some sensors, sensing, processing, and output, storing. Storage or actuating or something. Sensing, processing, store, actuate, something. So that is the data flow. Data is created, generated, processing, and passed to the so next node, process like this. This is data programming is very good for such IoT programming. Then that's why so I'm researching about this topic. This is a node-RED environment. In a node-RED environment, we have two items. One is a node. Node is this block is a node called node, and wires. Wire is connected to the connected between two nodes. Wire connected. So some data is generated in the left top inject node. That is generating the new data or a new packet at the first point. That is a data source. Then pass to the next node process, pass to the next node process. That is a series of the node-RED and the node. That's IoT programming, like IoT programming, like this. Okay, so how to implement? Implementation is okay. Implementation is okay. So that is arranging blocks and connecting the wire. That is okay. So how to execute this program is the next problem. Okay, this node environment is on the browser, we can execute, that is okay. And the server side, that is okay. But my target is small devices. How to execute such program in the microcontroller is my topic, my research topic. So I am talking today about this topic. So how to execute this data flow design implementation on the microcontroller. The answer is very simple. Answer is that passing the data from the one node and the second node, first node, second node, passing data. Data is stored in the queue, some queue stored. And the queue from the queue, and then analyze, dispatch the queue packet, then next process. So inject node, that is the data source, is enqueue into the queue, global queue. And dequeue from the queue and analyze, dispatch, then process. That's all. So two phases, only two phases. The inject, that is the data source, enqueue to the global queue. And the second is processing node, other nodes are dequeue from the global queue and analyze, dispatch, execute, that's all. So that repeating this sense, then this nodelet data flow programming environment, data flow discretion in the microcontroller. That is realized by this idea. Okay, so integrating this mruby environment microcontroller and data flow discretion. How to integrate? How to? This answer is very, very simple. This one. So I already released nodelet to mruby. So this script can generate the mruby code from the nodelet data flow description. So input is the data flow description that is relating the node, wire. That is the description of the nodelet data flow description. That is the input. And the output is Ruby code or Ruby bytecode, mruby bytecode is generated. This is nodelet or data flow description here. First node, this is the first node. Many information is listed, but in execution time, only this red line enough. Other items, other properties, they are placing the location, size, color, or something. That is no meaning in execution. So we remove such not necessary information, entries, properties, and convert into the mruby code. So this is a demo program. First demo program, this one, first demo program. This demo program is two series of the data flow, two data flows. First data flow is blinking green LED. This one is 1 second each, blinking 1 second each, this one. So first node is creating, generating timing, the injection, data source, data generated as the first node. And second node is, this is like D flip-flop. So you know D flip-flop. The signal is, trigger is coming to this trigger node. Then first time output 1, second time output 0. Third time output 1, so 1, 0 is flipped. This is this trigger node, middle node, that one. That is working behavior is the same as D flip-flop. And final case is LED, green LED, the blinking. And the second flow is 2.5 seconds each. The timing is 2.5 seconds, trigger. And trigger is D flip-flop, flip 1, 0, flipping, flip-flop. Then finally blinking, turn on and turn off the red LED. So this is a very interesting behavior because this microcontroller is a single core, of course, single core, and single program only. By the way, so MrubyC is supporting multi-programming, okay. But in this case, only one program is executing on this microcontroller. But like asynchronous application, two LEDs blinking so independently, but only one program. Okay, this is a generated pseudo program, like a pseudo program. Sorry, the character is very small. The point is 3 points, 3 points. 1 point is injection, data injection. That is the data source is generate one packet into the queue, NQ, each timing. 1.0 second, 2.5 seconds, and so on, injection. And second node is, second point is processing. So NQ from the global queue and analyze, dispatch which behavior. Sometimes D flip-flop, sometimes trigger, or sometimes threshold, or something. Sometimes Ruby code is also okay. Ruby implementation is also okay. So some behavior, some execution in the second step. And the third one is, so can you see the last line, sleep. The sleep statement is that is a sleeping. As Ruby has a sleep, same as a sleep. But in microcontroller, sleep sentence is goes to the deep sleep mode in CPU. CPU goes to deep sleep mode, and for a while, interval time. After interval time, then wake up the CPU. Then work again, go again. So this one is also, so asynchronous execution is done by this mechanism. And also the deep, power consumption, low power consumption is realized by the final line sleep line. So that is good for the IoT devices. Okay, now I conclude my topic. This work is now continuing, not closed, not completed, now continuing. So future work and just idea is dispatching performance. Dispatching is not so good performance, lower performance. So I want to adapt or improve this processing. And maybe IoT is something related to the distributed systems, like edge computing or centralized computing or some node computing or something. That is very related to the distributing system. So this node or data flow programming is sometimes can be adapted to the such distributed system. So I want to adapt or do something that idea and deploying. So in such distributed system, so how to deploy each program to the devices, main devices, how to deploy is another problem. So recent problem, another problem. So I have no idea about that distributing system, vertical distributing in the distributed system. But maybe that is an interesting topic of my research, I think. So finally, thank you very much for many persons related to the mruby and mrubyC. Mainly, so mrubyC developers, very thank you for everything. So Higashi-san and Hasumi-san, very thank you for the mrubyC virtual machine implementation. And ITOC, that is a local government research center, is supporting this research. And also QTech is my institution. QTech students, so student work, sometimes student work is related. Student work. And also National Institute of Technology, Matsue, Professor Sugiyama, professor, and also the student in their lab. Many help is many supporting from the such student. Thank you very much. And these references. So if you are interested in mruby and MVC, please refer this GitHub site. Or after now, I'm joined to the official party tonight. So if any questions or any advices to me, please find me at the conference party. Thank you very much for listening today. Thank you very much.